Hello everyone, I'm Matthieu Dussauze from France Énergie Marine, and today I will introduce you the public webinar dedicated to the question of ecotoxicology of cathodic protections. This webinar is based on the results of the ECOCAP project. So ECOCAP, the title of the project was Assessing the chemical risk of elements released from galvanic anode and impressed current on the marine environment and its food webs. This project was supported by the French National Research Agency with the France 2030 funding, and with additional financial support from Région Sud, Région Bretagne, and Région Normandie. Here you can see also the partnership of the ECOCAP project built with the knowledge from academic, industrial company. So just to have a quick look of the speakers of the webinar. Myself, Matthieu Dussauze, from France Énergie Marine, I will talk about the context and all the ecotoxicological aspect of cathodic protection with my colleague Nicolas Michelet from also France Énergie Marine. After Christelle Capla from Université de Caen Normandie will introduce some aspect of GACP release. Christelle Capla was a principal investigator of the ECOCAP project. Then Jean-Luc Bouden from Aix-Marseille Université will have a talk on ECCP release. And finally, Emma Goose from EDF Renouvelable will introduce the point of view of industrial in this kind of research and development project such ECOCAP. So here's the agenda. So first, I will introduce the context of the question of ecotoxicology of cathodic protection in the offshore renewable energy. So then Christelle will define the nature of GACP release. Nicolas Michelet will present to you the results of ECOCAP project on in situ measurement and modeling approach. Then I will conclude on GACP, so by introducing you the ecotoxicological results of ECOCAP and the chemical risk assessment for aluminium performed during ECOCAP project. After this moment on GACP, Jean-Luc Bouden will introduce the first result of chemical released by ECCP, impressed current cathodic protection. Then Emma Goose will talk about the point of view of an offshore wind farm developer, And then, to conclude this moment, Christelle Capla will discuss about the main results, the conclusion of the ECOCAP project, and the perspective of this thematic. As you can see, there is a moment for question and response session. So don't hesitate to write on the chat some question. Depending on the time, we will try to respond to your question. So this webinar, the duration of the webinar is about 1 hour and a half. And during this 1 hour and a half time, we will try to have 50 minutes of question. So now I will introduce you the context of the ECOCAP project. Here you can see a picture of actual and future offshore wind farm for French facade. As you know, offshore wind has rapidly become one of the most dynamic technology in the global energy mix. For example, in Europe, 3.8 gigawatts of new offshore wind capacity was deployed during the year 2023. So this dynamic is in line with the European Union regional offshore energy target, which aim to reach 111 gigawatts of cumulative capacity for offshore wind farm by the next 5 years, and by 2050, the goal is to reach 320 gigawatts. In France, the total nominal capacity of offshore wind is just under 1.5 gigawatts. Additionally, another 1.5 gigawatt is currently under construction, and 1.9 gigawatt has been awarded. So as for Europe, in France, the market is growing rapidly, and the French programmation pluriannuelle de l'énergie target to reach 10 gigawatts by the next 10 years. So in this context of massive deployment of offshore renewable energy in Europe, but also in France, several environmental pressure generated by offshore wind were targeted as high concern. We can mention noise emissions, risk of collision for birds, or emission of electromagnetic fields. And in this context of environmental pressure generated by offshore wind, the one from chemical was related the chemical risk, related to offshore wind farm and its potential impact for environment was highlighted by the French public authorities and also by the French civil society as a real concern. The main issue for this context of ecotoxicological risk for offshore wind is the use of GACP, so galvanic anode cathodic protection. This system of cathodic protection will limit the corrosion of the metal structure in the marine environment. And GACP has been identified as a significant source of chronic metal inputs of the marine to the marine environment. Here you can see in the picture some jacket foundation from the offshore wind farm of Saint-Brieuc, and if you look at the zoom, you can see the anodes. So there is many galvanic anodes in this kind of foundation. Depending of the commercial formulation of the galvanic anode, but the galvanic anode can contain at least 94% of aluminium and around 5% of zinc. But the offshore wind farm developer are increasingly using ECCP system, so impressed current cathodic protection, to protect their offshore structure against from corrosion. One of the objectives of this change of system is to reduce the metal discharge into the environment. Compared to GACP. However, our knowledge, our understanding on the environmental pressure potentially generated by ECCP are very limited. The question for chemical risk is important. Some other component of offshore wind could release some chemicals. This is the case for anti-corrosion paint, and just to have a look, a very recent study from Engsman et al. Report that for offshore wind farm activity, about 220 organic or inorganic chemical could potentially be released into the environment. So to effectively understand the chemical risk associated with offshore wind farm activity, the key challenge is to define the environmental pressure resulting from chemical emission. This involves evaluating specific compounds, but also complex mixture. We will see that for GACP or ECCP, so complex mixture from offshore wind farm release. But if you consider offshore wind farm activity in the marine environment, you have to also consider potentially cumulative inputs from other activities such oil and gas or such from riverine inputs. So that's the main challenge of the thematics. However, we faced a lack of knowledge to assess, anticipate the potential environmental impact of the chemical release from offshore wind farm activity. In this context, the ECOCAP project has for main contribution to produce a knowledge basis of the potential environmental impact of anti-corrosion protection, so GACP, ECCP, and also anti-corrosion coatings. More precisely, ECOCAP objective was to conduct first a series of acute and chronic ecotoxicological studies on aluminium and on the cocktail from the GACP, so aluminium, zinc, and other metals elements such as indium or gallium. The second objective was to improve the definition of the chemical pressure generated by the use of ECCP system. The third objective was to try to improve the assessment for the environmental risk of anti-corrosion paints, the contaminant mixture, and also improve our knowledge on the potential bioaccumulations of some element from offshore wind farm activity in marine food web. Finally, the ECOCAP objective, the final ECOCAP objective is to characterize the chemical risk for water column associated with the release of elements from GACP and ECCP. For that, we in ECOCAP project we followed the rich technical guidance for this chemical risk assessment. It's a 4-step procedure. The first step is to perform an inventory of chemical substance potentially released in the environment and try to understand their fate and behavior in the marine environment. Then to assess the level of exposure in some case study area. For that, we define some peak predicted environmental concentration. After defining the level of exposure, we define the level of hazard by defining a predicted no effect concentration for marine water, so PNEC. When you've got your peak and your PNEC, you can characterize the risk for the targeted element. So it's a PEC-PNEC ratio. If your ratio is lower than 1, there is no expected risk for the environment. And if your ratio is higher than 1, there is a potential environmental risk. So Here are the objectives of the ECOCAP project, and now I will let talk Christelle Kapla, which will introduce you the physical chemical characterization of galvanic anode, GACP, release element.